Welcome to my office. Just thought I would introduce this problem. It's pretty self-explanatory, but I'll give you a couple little tips and tricks. You probably have seen some of these physics aviary simulations before, but if you haven't, this is an example of one of their homework questions. So when you do it, you can do it as many times as you want, but it's going to make up different numbers for you each time. And then the solution, obviously, is going to depend on those numbers. So I'll show you how it works, and I will give you some good hints that might help you out. So if you click begin, it takes you to the problem setup. We have, you can see here, let me point with my mouse so you can actually see what I'm talking about. This is a big beverage cooler. So big cooler full of some kind of liquid. And then there's a spout down here. Notice this lines up with the bottom. So this line is measuring from the bottom of the spout to the top of the fluid. And then when you click the faucet here, it's going to open the faucet and liquid is going to start filling this beaker. So the question you are ultimately trying to predict is how long is it going to take to fill this beaker up to a height of 1 meter. And like I said, the numbers are going to change every time. So you'll have a different height of fluid here in the container. This one really threw me for a loop the first time I looked at this problem. They give you a different value of G every time. Usually G is 9.81 meters per second squared because usually we're on Earth. They take you all throughout the fictional universe to lots of different planets. So be real careful. Don't put in 9.81 because G is going to change. The faucet radius is the radius of the opening down here. And then the density of the fluid is also going to be different every time. You're probably used to just using water, which is 1,000 kilograms per cubic meter. They're going to give you different densities. So be real careful with those units because if you use the wrong G or the wrong density of water, you're not going to be able to get it right. With that being said, you can make the assumptions that we made in the last video I posted. You can assume that this flow rate is going to be so small and this beaker or this cooler is so big that you can assume that the water on the top is motionless. You don't have to include that in your calculation. Hint number 2 is going to be real careful with the units. So they're giving you measurements here in millimeters and millimeters. You're going to want your units to line up. And then you're also going to need this over here. This is the radius of the collection beaker when you're doing your conversions. Also be careful with the units you see on the side here. They want the exit velocity in centimeters per second, the flow rate in liters per minute, and then the time in seconds. So the reason they have those funky units, I think, is to make sure you have answers that you don't round. So if you're looking at sig figs and things like that, they want you to have a few decimal places so you get a nice chunky answer so you're not rounding to a single digit. But make sure you give the units that they're looking for, otherwise you won't get it right. So how do you get credit for this assignment? Make sure you type your name in this box and your answers in this box. Let's make them up, see if I can get it right. Oh, exit velocity, I think 348 centimeters per second. Notice I'm not typing in units. Flow rate, liters per minute, I don't know, 0.64. Time to 1 meter, 20 seconds. So once you have these entered based on your calculations, click the faucet and let's see how we did. Looks like we have a little timer going over here. Ooh, I think I'm going to be not right at all. So 8.6 seconds. It says, Schmidley, sorry, your calculated values were not within the acceptable range. Exit speed, cool. So they have the actual answers here, and then they have my answers down here. I was, closer on some. 0.64 liters per minute is actually, not exactly what they were looking for, and that's okay. But notice that's the problem. So I can't go back and have those same numbers. So you get them or you don't. If we refresh the page here, it takes us back to begin, and we've got a different G, different radius, different density, different height here. I think this 56.4 might be the same every time, but don't assume that. Always double check it. So if you get it wrong, you can still try the problem again. You can still get full credit, but you're going to need to do the math again, which brings me to my number one point, or my number one hint. When you're solving these problems, work through them with variables. Derive an equation for the exit velocity. Derive an equation for the flow rate. Derive an equation for the time to fill to 1 meter. Then plug your variables in. If you have the equations, and maybe you get the first couple right, but you get the last one wrong, you don't have to do the math again. You can keep your equations, plug in the new values you get the next time, and you don't have to rework everything. So really, really, really encourage you to derive your equations. So what you have to do to get full credit for this assignment is type in your name, correct answers to these questions, and then run the simulation. And you need to just send me a screenshot that has all of your answers correct, and giving you that nice little victory screen that you get at the end. This has taken an awkwardly long amount of time, so I could sit here in silence with you watching it. I could speed up the video. Probably not going to do that. I'm okay rambling. I can fill the sound. I can fill the time here. Imagine the Jeopardy theme song. I'm watching a squirrel bury a walnut right now. It's pretty exciting stuff. Almost there. Wow, 46.2. My guess of 789 seconds was way off. Too bad. So you just need to send me a screenshot showing your name at the top here, along with the congratulations. You got them all within the acceptable range. And if you have any questions as you're working, let me know. And this is an assignment on Schoology. So take a screenshot or a picture, however you want to do that, and then upload that through your assignment on Schoology. Don't just email it to me. I'm not going to grade it if you just email it to me. Send it that way. So happy deriving. Those equations will be your best friends. If you have any trouble with this, please send me a message so I can help.